College of Engineering, Goodwa, in collaboration with Pencil Bits. So VKR and VMB and VJK College of Engineering, established in year of 2008, it is a self-financing institution which has owns its foundations to build and inspire the vision of general and technical education, the Society of Gundua. The institution is ideally located in the vast expansion of 15 acres of land on the outskirts of Gondwa cities. It is the departmental building and the located in the close proximity of each across each other, wide options, wide space all around. The playfield and other students and the staff amenities within a working distance from the faculty blocks. The college was established in providing the technical manpower initial in the field of computer science engineering, electrical and communication engineering, and electrical engineering. Since the college has been continuously evolved itself to meet the changes in the field of engineering. The undergraduate course in the civil and mechanical engineering, besides the two postgraduate course in the field of M.Tech, CSE, VLSI, and thermoengineering, the Master Business of Administrations. The college is recognized by the AICTE, the All India Council of Technical Education, Delhi. The college of affiliated in the Jawaharlal Nehru, the Technical University, Canada, and the Andhra Pradesh. The college is about the 1,400 students, more than 110 faculties, and around the 70 technical supporting faculties. The hallmark of the campus is the good faculties which create the academic extracurricular interest of the students. The campus provides the amenity of the opportunity to develop the extracurriculum skill like included NCC, NSS, and students chapter of IEEE, and the social clubs and the sports games. The alumni of these institutions has excellence in the various phase over are positionized with the very well global in the number of leading government and the public sector and the private organization. It has revised and updated with the course of content and laboratory equipments from the time to time and keep the pace of the changes in the technicals and in the meet of growing the need to the industries. The college offers the conducting environment to the research entity with the member of faculty has been processing the active research, providing the large number of research publications and improving their qualifications. The management has been encouraging the faculty to organize the various research-oriented seminar and conference. This year, our college is accredited by the NAC of A grade and autonomous of 10 years of services. So I take this time to invite our today's speaker, Sujitra ma'am. Mr. Sujitra ma'am is working as an assistant professor in the Department of Computer Science and Engineering at Sri Ishwari College of Engineering. She has completed her BTech and ME degree in the Computer Science Engineering domain at the Anna University, Chennai. She has obtained her MBA in the Human Resource Management from the Bardiyar University. She is gold medalist in both UG and PG program. She is currently pursuing her research in space data analytics at the Anna University. She has teaching experience of 11 years and a technical authentication research who has published 13 papers, 10 patents to her credit. Out of 2 patents has been granted. She has authored of 2 books in artificial intelligence and cyber security. Her area of specialized in the data structure and algorithm, object-oriented program with the Java network and cyber security. With the Wipro certified faculty, she is organized as a mentor for the project-based learning in Java full stack from the Wipro Technologies, Bangalore. She has Intel and created the certificates of Intel Recurrent Toolkit for the machine learning for on APL, SC, SYCL essential from the CUDA to the CYCL. She is in a specialized lab in the training of cyber security faculties. She is cybercrime investigation officer and the cybercrime incidents responsible. She has received the fund more than $500 of established of WICYS students chapter and the faculty mentor in WICYS CECS students chapter. She has served as a resource person and keynote speaker to the various events. She is a reviewer for the International Conference on the Electrical and Computer Science and Communications and Mechatronics and Engineering. She has a lifetime membership in ISTE and she is remaining as a doctoral board member in the many students campus. She has student startup. She is CWY educator and she is an SPOCS in the British Petroleum Monitoring. Welcome you, ma'am.
Thank you. Thank you for the introduction. Um, so, okay. So we are going to discuss on deep learning techniques. This is one of the area where I am specializing, and my PhD is completely relied on deep learning techniques. So we are going to have a discussion on. Most of you would have been working on deep learning, machine learning. So we'll be discussing on the different techniques and what I have experienced in my PhD profession. PhD research and in my profession. So what in all I have learned, I'm going to share it here. And what are the different ways or different techniques we can use in deep learning is all. These are all the things we are going to discuss in this session. So, as my introduction goes, I'm Suchitra. I'm working as an assistant professor, selection grade, the Department of CSE, Srisha College of Engineering, one of the topmost institution in Tamil Nadu. And so, this is the agenda for the day. So, we are going to see what is the introduction of deep learning, the aims and objectives of deep learning, and we're going to overview what the deep learning concept is all about and what are all the application areas we have in deep learning. And I have taken up a scenario of deep learning. So what is the scenario of that, and what are the trends we have in deep learning, and what are the research issues we face in deep learning. And finally, there will be a conclusion and what are all references I have taken up, and finally the acknowledgement part. So this is my agenda for today. So let's start with the introduction. So when you take up deep learning, what is basically deep learning? The name itself suggests that you are just having a learning part which is deeper in knowledge. That is the basic idea of deep learning. So when you speak about the technical way of defining deep learning, we'll say deep learning is a type of artificial intelligence which uses artificial neural networks to teach computers how to process data that always mimics your human brain. So that is the basic idea of deep learning. Deep learning is actually, I'll repeat it once again, is actually a type of artificial intelligence which uses artificial neural networks. Okay. So using this, what you're going to do is you're going to teach the computer how to process the data which will mimic your human brain. And if you take up deep learning models, they can analyze data from multiple sources in real time to recognize patterns and produce predictions. So this is all about deep learning. So as the picture itself suggests, artificial intelligence is the whole of a area where machine learning is a subset of artificial intelligence, and also deep learning is a subset of machine learning. Yeah. So when you talk about deep learning, it is always to stimulate your human brain in decision making which is connected with the system. So what is artificial intelligence? We all know what is artificial intelligence. It is just an artificial intelligence era where we have everything automized, right? So when you take up artificial intelligence is a field of science which involves building machines, computers, which can learn, reason, and act in ways that usually requires human intelligence. Whenever you need a human intelligence, we are going to make the computers learn, reason, and act. That is important. Okay, LRA, learn, reason, and act. That is important. Yeah. So we are going to make a system, a computer, learn, reason, and act as per in par with the human intelligence. So when you take up AI systems, it is like you have a variety of tasks to be performed, from a simple to a repetitive task, from a complex to cognitive task. So you can do everything, each and everything here in AI. So when you speak about AI, I told you three things to be remember: learn, reason, and act. So learn is like it has to understand. Yes, it has to understand. What it has to understand is it has to recognize the speech, it has to recognize the pattern, it has to recognize the trends, it has to understand what text it is being used. So basically, this is the basic idea of learning. So recognizing text, recognizing speech, the patterns, the trends, and to predict the future conditions. So this is the basic idea of learning in artificial intelligence. And the second thing, what I told you, is all about reasoning. So when you have to reason something, when we take up, we always reason about our day-to-day activities, right? So when we have to reason on something, we always analyze the situation. Yes, analyze the situation, and then we'll make the decision. Finally, the decision will be given out as a reason to us. Yes. So the basic idea of reasoning is analyzing and then making decisions, right? So analyzing is like you have to analyze the data, you have to interpret what is being learned, and you have to adapt it. That is the basic idea of um, reasoning. And making decisions is the second part in reasoning, where you have to predict. You have to predict if this, if A and B are there, I have to interpret it in a certain way. So it has to understand the basic idea of the decisioning, and then it have to take it up. Yes. So usually AI is all about three things. One is learning, reasoning, and act. So learning, I told you, to learn about the speech, text, patterns, and you have to predict. And if you take up reasoning, there are two parts. One is analyzing, and the second one is making decisions. So analyzing is analyzing the data, interpret it. And making decisions is all obviously you have to understand the situation and then make up a decision. So this is the second part. And the third one is act. Act in the sense, when you learn something, when you reason something, obviously you're finding a solution. You're going to act upon the problem, and therefore you're finding the solution. So you're going to solve the problems. So AI systems proactively solve the problems, right? So these are the three parts in artificial intelligence. So the definition of AI goes like this: the theory and development of computer systems that are able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, and decision making, nature language processing, that is translation between languages. Yes. So what are all the areas of specialization you have in AI? Whenever you take up any gaming, as of now, when we play anything, the gameplay always involves the other person. We always play games with our mobile phones, right? Or in our system. So the opponent will always be a computer system. Yes. So to have the computer system as an opponent, obviously, excuse me. Yeah. So if you have an opponent as a computer, obviously there should be AI involved, right? So when you take up game playing, the artificial intelligence plays a major role. Obviously, robotics, natural language processing, the one we always use, Gemini, ChatGPT, Siri, Alexa, are all the biggest example of natural language processing. Expert systems, when you go anywhere, when you find any KIOSK systems, That is the example of expert systems. And all these gaming, robotics, NLP, expert system, everything is being constructed using neural networks, right? So some examples I have given here. One is playing the chess, which is when we do it in our system or when we do it in our mobile phones, obviously that or the opponent is going to be a computer, and therefore you will have a AI playing with you. And when you go for any travel as of today in India, not only in India and across the world, but most probably when we go anywhere, we could find that you have a fast track reader with you. Yes, you would have paid something. So there will be an AI machine which will recognize your number plate. Once your number plate is recognized and it has been already paid, if you have already paid for the fast track, you will have the bar raising up, and you'll pass the corridor of checking, right? So if you take up all these systems, number plate recognition and all, so when you have a toll gate and the toll gate recognizes your number plate and it gives you a data that so and so value has been paid by the customer. So obviously there is an involvement of AI, right? So there is a visual capture of your number plate. The data is getting verified at the back end. Yes. So one example of day-to-day activity we see is number plate recognition. And when you take up natural language processing, obviously Siri, Gemini, Google Translator, everything. Yeah, Google Assistant, everything, they just check with the voice, right? They recognize the voice, they convert the voice, add it up as a data, and then they'll give you the output, whatever you want to add up. It can be anything, right? We used to search a number of things. So this is one such example we have in our AI application. So now this is the evolution of artificial intelligence. Obviously, AI started its evolution in 1950s. Yes. So AI was like you have to make intelligent machines and programs. Dear professors, just remember one thing. Whenever we have any technology, the technology evolutes itself for at least 50 years. And at the end of the 50th,
Ma'am, voice muted, ma'am.
I'm so sorry. I didn't know. Somebody has muted my uh, microphone. Sorry.
Ma'am, again muted, ma'am.
Who's muting me? I don't know. Hello. So should I repeat it again? So is it muted for few seconds or was it muted from the beginning?
Few seconds only, ma'am.
Okay. Thank you. Thank you. So when you take up AI, so as I was saying, you have evolution of any technology that will take up 50 years to come up into prominence. So the biggest example of that particular is artificial intelligence, where the evolution started in 1950s. And of course, the prominence of artificial intelligence was driven high in 2000s. Yes, so it almost took 50 years for any technology, not only in AI, for any technology. It started with, say, for example, if you say about C programming, yes, it started in 1900s, and During the end of 1950-60, C programming came into prominence. So it will at least take, as I said, it will at least take 50 years to just make out the technology into a very prominent one. So yeah, I was saying about C programming, right? So C was the work on C started in 1920s actually. I mean 1920 something. But when Dennis Ritchie at Bell Laboratories, he came up with the peculiar idea of C programming in 1972. So at least it took 50 years for people to understand, for people to work on one particular technology, and that technology at least will take another 50 to 60 years to stay on the market. Once the technology has done its purpose, it will die away. So that is always we have seen it. Yes. So the example for that is applets. We all know we once upon a time we were using button mobile phones, right? So inside button mobile phones, we always used applets to. I mean, I still remember in 2015s I used Nokia Asha 210 where I had WhatsApp in that phone. That was the, I mean, 2013, WhatsApp was invented. And when I was using Asha 210, it was around 2015. So we had applet technology installed in our mobile phone. And with that, we accessed different types of applications. But when smartphone came into picture, obviously applets, the concept of applets died away. And it took another form. The applets, the concept of applets, it took another form and it came out as Java Swing, it came out as Java FX, right? But applet died away, right? So this is the basic idea of any technology. For an evolution of a technology, it will take at least 50 years to reach its prominence. Once it reaches its prominence, it will stay there for another 50 to 60 years. And once it is done, it will die away. So this is the uh, timeline of any technology. So when you come back to artificial intelligence, it started with 1950s, it evolved till 2017s. So machine learning, it started in the middle of 1980s, but the basic idea of artificial intelligence when it started was to make intelligent machines and programs. That's it. But when machine learning came into picture, that is as the subset of artificial intelligence, the main idea behind machine learning was the ability to learn without being programmed. That was the basic idea of machine learning, right? So you don't need to program anything, but if you get a question, there should be it should the system should be in a position to answer. So that was the basic idea of machine learning. And the next idea of machine learning was deep learning. So deep learning, as we said, we all know what is deep learning. So what you have is you have a deep neural network. The idea of neural network comes into picture. So you have a deep neural network, and using this deep neural network, you're going to learn the particular problem, or you're going to find the solution in detail, in peculiar, accurate. Yeah. So this is the idea. So deep learning came into picture around 2006, after 2006. So when you take up machine learning, you have different types of there are wide variety of applications of machine learning, starting from natural language processing, spam detection, cyber security. And we all know we have been given a very good insight about what is a supervised learning, what is an unsupervised learning, what is a reinforcement learning, right? So just for a few seconds, I'll brush up what is supervised learning. When you take up supervised learning, you have a training model, right, with a labeled data set, right? So it will be like if you have, if you have a data, you're making sure that there is a purpose for the data, and you're giving all type of support for the data. That is what we say it as labeled data sets, right? Whenever you get all the support for a data, in the sense all the columns, rows, everything is being filled. The data is perfectly aligned, and you just don't want to have any explicit data coming in. Everything is organized. There is a purpose. So obviously, you say that as supervised learning. Whenever you take up an unsupervised learning, obviously there will be no labeled data. You'll term it as unlabeled data, right? So there will be patterns which is unlabeled, which can, it will be like the data will come explicitly. You don't have any peculiar organization. Yes, so it will be like you're going to just do it as such, and the machine will start learning without any direction. Yeah, so that is called unlabeled data. So um, the one such example is clustering, right? So you are going to organize the data uh, from an unlabeled data. You're going to find something out of the context, in the sense it is not in an organized way. It is never defined what is going to be done. Yeah, so in such situations, so basically if you define unsupervised learning, it's all about a machine learning technique which uses algorithms for analyzing unlabeled data. In the sense, you are not labeling it anything. There is no outcome. Nothing is going to happen. But still, the machine will try to learn itself. There is no supervision there. There is no peculiar instruction given to the computer for learning. Right? So that is called unsupervised learning. So if you take up unsupervised learning, you have clustering is one biggest example where you're going to cluster the data based on one peculiar that involves deeper concepts, but still I'll tell you that based on one particular uh, yeah, sorry, I just got a call here. Okay, so you're going to classify your data. You're going to cluster your data. It's not classification, it's clustering. So you're going to cluster your data based on one particular idea, in the sense one particular parameter. So that is called clustering, and we have examples like k-means clustering, and we have dimensionality reduction techniques, etc. That comes under unsupervised learning. And there is one more learning which is called as reinforcement learning, where there will be, it's all about trial and error method. Yes, and if you achieve the target, obviously you will get a reward system. In the sense, the target is getting achieved, so obviously you're being rewarded. Okay, so that is reinforcement learning. So these are all the concepts that involved in machine learning. So you might be thinking, we have all such things inside machine learning, and why do we go for deep learning now? So when you talk about deep learning, obviously the involves a concept which is called as neural network. Okay, neural network is the important word in deep learning, and neural network is a model which is like, when you speak about the neural network, you have to understand the biological representation of a human. So obviously there will be biological. We all know how a biological neuron work. It's the basic component of central nervous systems, where your neurons are connected with each other, forming neural circuits. Whenever we touch, somebody touches us, whenever we get anything anxious, we react to something, everything happens with the neurons. So obviously the neurons are connected with each other, they reach the central nervous system. From the brain we decide. Yes, so this is the basic idea of biological neuron. So what people are trying to do in deep learning is all about creating an artificial neural network which will work similar to the biological neuron. It's like there will be an input. Obviously, we'll take up a similar example. I'm going to touch this particular place. What happens? I feel my central nervous system, which is connected with the brain, recognizes that Suchitra's hand is touching the table. Yes, that is what is the stimuli I get from my brain. Similarly, if you take up artificial neural network, okay, it will be like you have a input given to you, and from the input, with the whether the data is recognized, whether the data is supervised or unsupervised, reinforced, nothing is being taught. So whenever you get an input, there should be the predicted output with you. The output should be recognized, like that of a biological neuron. So what they're trying to build is they're trying to build an input layer which will get the input, and there will be a hidden layer which will which has certain types of functions. Okay, we'll see that later. So we'll have a hidden layer which will have a decision making, which can be a decision making layer, which can be used for finding anything. Okay, it can be like any trans activation function, transformation function, anything that comes under hidden layer, from where you are getting the decisions. And there comes the output layer, which gives you the output, right? So this is artificial neural network. So from the artificial neural network, using artificial neural network, you're going to predict your output. Okay, so that is the idea of deep learning. When you take up deep learning, obviously, you'll have neural networks involved in it. There will be some functions, some prediction, and there will be hidden layers. So always deep learning involves, remember, always deep learning involves artificial neural networks. And when you speak about artificial neural network, obviously there will be an input layer, output layer, and a hidden layer. In the hidden layer, you will have all the activation, transformation, what all techniques you want, that will be incorporated. So obviously, we just had a discussion on what is machine learning now. So machine learning is a type of artificial intelligence which provides the computer with the ability to learn without being programmed. Right. So what example I have given here is you have an input with some length, some width, and there will be a petal length, there will be a petal width, something like that. You're getting the input inside. Okay. And inside from the input, the input is getting processed inside the AI machine. I have just created the AI machine like a robot. It is not necessary to be a robot, can be any machine. So inside the machine, it is being decided what could be the output. Okay, from the input, from the peculiar length, width, petal length, the petal width, there is some input given inside. From that, the output is being predicted and it is being given out. So what happens here inside the artificial intelligence machine is they the machine will already have a data set, okay, which will have like, if the length of the flower falls in between from this value to this value, if the width of the flower falls in between this value and this value, if the petal length falls in between some values, petal width falls in between this certain values, the output will be a sunflower, the output will be a rose, the output will be a lily. That could be the output. So with the given input, the machine learns from the data set and it gives out the output. So this is the basic idea of machine learning. Okay, so why do we go for machine learning? So limitations of machine learning. So what could be the situation? Why it is why are machine learning? We have so many things to be discussed in machine learning, and there are many advantages. But still, what could be the situation that demanded your machine learning to be moved on into a deep learning concept, right? So the major problem with machine learning was a process which is called as feature extraction, that comes under image processing. Okay, so if you have a complex problem, such as like to recognize the object of a handwriting, okay, so such things, it posed a very big challenge for machine learning. Feature extraction was the biggest challenge machine learning faced. So whenever you have a traditional model of machine learning, um, the feature extraction remains a biggest problem. And why it became a problem was sometimes the machine may misinterpret. Okay, sometimes the machine may misinterpret. So that is the biggest issue. Interpretability was the biggest issue in feature extraction. So when I mean, in some cases, I'll tell you, if you have a real world scenario, there could be overfitting, there could be underfitting, right? So overfitting occurs when a model is too complex for the data it is supposed. We all know what is overfitting, right? Overfitting is like you will have if this from you'll have so much criteria in overfitting, right? That's called overfitting. And when you speak about underfitting, you will never have conditions. That's called underfitting, right? Overfitting is like when from this to this, from this to this, you will have so much of conditions. That's called overfitting. When you speak about underfitting, there will be no conditions. That's called underfitting. So overfitting and underfitting can be a problem in feature extraction. Okay, in the sense there could be situations where uh, the features of two objects could be same, and the machine has to opt for object A, but it would have opted for object B. Yes, so that posed a very major problem. So the major problem, the major limitations of machine learning was feature extraction. Inside feature extraction, what was the biggest issue? It was interpretability. Interpretation of one particular feature was the biggest pose of challenge in machine learning. And to speak about interpretability, obviously you have to understand what is overfitting and what is underfitting. So if you take up overfitting, overfitting is all about having so much of conditions for getting an output, right? So it will be like when you overfitting, if you take up a new data, you will be it will be easy for you to classify, right? Underfitting is like you will never have condition, so that will you will get the output, you will get the input, you'll just keep it up somewhere inside the data set. That's called underfitting, right? So that overfitting, underfitting, interpretability, all the problems of feature extraction. So that was the huge problem we faced. So now came with the limitations of machine learning, there came a rescue, which is deep learning. So what does this deep learning do? Deep learning are able, I mean, they are capable of focusing right features by themselves. Okay, requiring the guidance from the programmer. With a small amount of code, we are able to identify, I mean, we are able to focus on underfitting and overfitting with the help of ANN, artificial neural network. And we have something called as dimensionality problem. We all know what is dimensionality problem. When you have more than two dimensions, okay? When you speak about dimensionality reduction, it is always about if you have 2 to 3 dimensions. I mean, we always have X and Y directions. That is obviously known to us. When it comes to X, Y, and the Z directions, okay? If you have 3 dimensions, so we will just end up in I mean, say for example, if I have um, X value with a common point in Y value, it is easy for me to plot. When I have huge number of figures, huge number of features, all the features will be plotted inside a graph, right? So when it is one row, one column, it is fine. X comma Y, that is fine. When it goes to X comma Y comma Z, I have a dimension, 3 dimension, right? I have 3 conditions, 3 different conditions, and there should be a common point. So that becomes that was the biggest problem for machine learning, where when you take up deep learning uh, just focuses on dimensionality reduction. Okay. So before we start with dimensionality reduction, we have to understand what is predictive modeling. Predictive modeling is basically a probabilistic process which allows us to identify the predictor. What could be the next step? What could be the next step of this particular output? So that is being easily predicted. So that is predictive modeling. So these predictors will play a very basic idea in taking out the output of any model. Okay, so this is predictive modeling. Just remember this. And when you come to dimensionality reduction, is actually a process of reducing the number of features in a data set. But you will retain, you will have, then you could ask me a question, ma'am, if you are trying to reduce the number of features inside the given data set, will I get an accurate output using deep learning? Previously, yes. Why? Because when you take up deep learning, it always focuses on the important information. It will never let out the important information away, and it will not focus on the unimportant information. So when you take up dimensionality reduction, it is always a process of reducing the number of features inside the data sets. And also, it will retain the number of information as much as possible. Okay, so what happens here is when you reduce the dimensionality, obviously the complexity of the model will also reduce, and there is an improvisation of the algorithm which is to be proposed when you have a reduced dimension of data. And there are several number of dimensionality reduction techniques which are PCA, which is principal component analysis, PCA, principal component analysis. And there is something called as LDA, which is called as linear discriminant analysis. So these are different types of techniques when you use for dimensionality reduction. So dimensionality reduction is one of the biggest advantage of deep learning, which will help you in focusing what is needed and what is not needed. Okay, so one important thing we have to remember about deep learning is building the idea behind building deep learning algorithms is to build learning algorithms which will mimic your brain. So obviously, as I said earlier, whatever I feel as a biological human, as a biological nervous system, the same has to be identified, or the same has to be reciprocated as a artificial neural network. So that is the basic idea of deep learning. Okay. So the aim of this seminar, so far we are seeing about the introduction of the session, and the aim of this presentation is to review the concept, the different types of architecture, algorithms, what are all the trends we have, and the research issues in deep learning. So this is the basic idea we have. And my objectives of this session is three important objective. One is to discuss about the concept of deep learning by its definition, architecture, and the algorithm. So far, we have discussed about the definitions of different types of keywords in a deep learning algorithm, and we'll be learning the architecture and the basic algorithms in the upcoming slides. And one more objective, what I have is I have picked up some important research papers. I have done a literature survey on that I have included that also. That is a part of my PhD work. So I have included that also here. So we'll be reviewing the related works and what are all the specific application areas we have. This is the second objective. The third objective of this session is to find the research issues we have and what are all the trends we have in deep learning. So, what is deep learning? Yes. So, This is all about deep learning. When you speak about, I mean, I gave you a theoretical definition of what is deep learning when I started itself. And now this is all about, I mean, what all definition I'm going to show you from here onwards is completely relied on different authors, different scientists, and their findings. So when you take up Deng and Yu in 2014, they defined deep learning in their paper by this way: a class of machine learning techniques that exploit many layer of nonlinear information processing for supervised or unsupervised feature extraction and transformation for pattern analysis and classification. And deep learning typically uses artificial neural networks. That's one thing you have to remember. So, what is deep learning now? Deep learning, what did I say? What was the biggest challenge of machine learning? Was feature extraction, right? So, feature extraction is being focused in deep learning. Yes, the feature extraction can be supervised or it can be unsupervised, but you're going to do feature extraction here. That is the major idea of deep learning. And what are you going to do? You're going to transform it, and there is a pattern analysis and there is a classification. Okay, so I mean, what do a deep learning have? Deep learning will have machine learning techniques. Yes. So it can be a linear processing method or a nonlinear processing method, or it can be a supervised or an unsupervised feature extraction. It completely relies on how the deep learning we are going to term it. But here, Deng and Yu, what they try to convey is the major disadvantage in machine learning was feature extraction. So they are doing feature extraction there using, it can be supervised or unsupervised. Also, it can be linear or non-linear information processing. So that is why they defined their deep learning in certain way. Okay. And as I said earlier, deep learning always uses artificial neural networks. There is another definition of a deep learning, a subfield of machine learning uh, that is based on learning several levels of representation corresponding to hierarchy of features or factors or concepts, where a higher level of concepts are defined from lower level ones, and the same lower level concepts can be defined with higher level concepts. Okay, so this was defined by a group of scientists in 2015, where they defined deep learning as a subfield of machine learning, and they had different types of features or concepts. They're trying to define the higher level concepts from the lower ones, and from the lower level concepts with the higher level ones. That's it. So, sorry. Yeah. So deep learning is always a combination of machine learning and representation learning. So this could be a new terminology for most of us, which is called as representation learning. So I'll tell you something. Deep learning, I mean, so far I've told.
Ma'am, again muted, ma'am.
I'm sorry, somebody's muting. Okay. So deep learning is always a combination of machine learning and representation learning. This could be a new concept for you, which is representation learning. That could be a new terminology also for you. So, representation learning is basically a process in machine learning, again, where learning algorithms will extract meaningful patterns out of the raw data. We know what is information, what is data, right? When you organize the data, it becomes an information that is called, I mean, When you have, when there is a data that is raw, when you try to organize the data, that becomes an information. That is the difference between data and information. So when you take up representation learning, so representation learning again is a part of machine learning, where you are going to extract meaningful patterns from the raw data. In the sense, you have not organized your data. So from the raw data, you're going to extract what? Meaningful patterns. And with that meaningful patterns, you're going to understand the process. You're going to make it as a representation. It's called representation learning. Okay, so that is what is defined here. Representation learning is a set of methods that allows machine to be fed with raw data. Yes, and with that raw, you're going to interpret the pattern. Yes, you're going to find the um, algorithm. You're going to find the meaningful ideas from the raw data, and then you're going to represent it. That's called representation learning. So deep learning is a combination of machine learning along with representation learning. So one thing I have to discuss here is, according to Leakin, Bengio, and Hinton in 2015, deep learning is the idea of representing or getting high level concept from lower level concept, and vice versa. It can be the other way also. It can be like you're going to get the low level data from high level data, and high level data from low level data. That's it. And what is deep learning and what is it happening now? So it's like the very first, as I said earlier, the very first deep learning concepts started in early 1970s. Yes, so there were different types of papers which has been published, and there had been neural networks, and there had been research breakthroughs happening throughout, and there had been different types of problems, and they came up with different types of solution, and from there started deep learning's evolution. So the very first breakthrough, at three important concepts you have to understand in deep learning is, just a second please, 1 minute. Sorry people, I just had a class now, so somebody came in between, sorry. Okay. So we had three important breakthroughs in deep learning. The very first thing is vanishing gradient, and the second one is gradient descent, and the third one is regularization. So we'll go in the reverse way. We'll start with regularization, where regularization, when I told you already, I told you what is an overfitting. So you have n number of conditions connected with each other. That's called overfitting, basically. So when you take up a network, it is always overfitting. Yeah. So what happens here, when you have a huge overfitting condition, you always drop out. You always drop out the data, which is always overfitting. Okay, because when you overfit some datas, it will never give you an exact output. It will never give you an accurate output. You cannot classify the data. So that is the biggest problem with regularization. This is the first thing. Second thing is all about gradient descent. There is something called as first order methods. Okay. So when you take up first order methods, it's always you're just going to read. Before we start with gradient descent of first order method, I have to tell you something. there are different types of methods in the deep learning. Thank you. Yeah. So when you take up deep learning, it's always about first order methods, second order methods, and third order methods. So when you take up first order methods, it's always optimization. Yes, we all know what is optimization. When you have interoperability, when your solution satisfies interoperability, feasibility, reliability, it becomes optimized solution, right? So when you speak about first order method, it is always about optimization. So you have a derivative. I mean, if you speak mathematically, you have a derivative, first order derivative, uh, which is the solution. The coefficient of your solution is going to be a first order derivative. So that will be the objective function of the optimal solution. Okay. So to not make it a complex, I'll tell you in a simple way. When you speak about gradient descent, it is always about three methods. One is first order method, second order method, and third order method. Okay. So when you always start talking about first order methods, it's all about finding an optimized solution. So if you get optimized solution, that is your first order method. Okay. So when you take up first order method, if you speak first order method, it's like, just a second, please. Okay, so when you speak about first order method, it's always about optimization. So optimization in the sense you're going to find a solution for the given problem. Speaking mathematically, you will have the coefficient, there will be a derivative which is called as first order derivative, which is the coefficient of a solution. That is the objective of first order method, in the sense to find the exact solution which is feasible, interoperable, and reliable. That's called first order method. So there is a term which is called as stochastic gradient descent. Okay, stochastic gradient descent. So that is SGD. That's what is said here. SGD, stochastic gradient descent. So this is actually a standard algorithm to optimize the artificial neural network. Okay, whenever you create an artificial neural network, you will have a stochastic algorithm, standard algorithm, which will give you an optimized solution. So that is called SGD. So if you take up any deep learning problem, you will have one solution which is always be SGD, which is stochastic gradient descent solution. Okay. So when you, as we all know, when you're going to train a model, obviously 80% will be your training data and 20% will always be your testing data, right? So again, SGD will always have training and testing data, and you will have different types of parameters involved, and the parameters basically depends on the type of the problem you take it up. And again, there will be, if you are speaking mathematically, there will be local minima and local maxima. Obviously, local minima will be avoided in plotting the stochastic gradient descent. So, and it's so deeper. So as of now, if I start speaking so much of one topic, it will be boring. But as of now, you just understand that there is something called as gradient descent. You have three types of methods. The top method is first order method, which has stochastic gradient descent, which is an optimal solution. When you speak about optimality, obviously you have to speak about interoperability, reliability, and feasibility. Is something called as second order optimization techniques. So second order optimization techniques are like the solution will be, it could, the output is like, it could be an optimized solution or it may not be an optimized solution. The output is like that. But you will try to make your solution an optimized one. That is the idea of second order methods. Okay. So it's like you have an algorithm, a set of algorithm or algorithms. And there are many type of algorithms in second order method. One is Newton's optimization method. There are many number of second order methods. Okay, so the basic idea is you're trying to make your solution optimal. Okay, so obviously you're getting some solutions from the given problem. You're trying to make up the solution. You're trying to define the solution as an optimal one. You're trying to make the solution as an optimal one. So obviously, if you compare first order method and second order method, first order method is by default an optimized solution. Okay, first order method always will have a set of algorithms which are optimized. Yes, when you take up second order method, they are algorithms which will try, that is the difference between first order and second order, which will try to build your algorithm, which will try to give your output as optimized ones. Okay, so that is second order method. So second order methods are also optimized algorithms which will that's a powerful class of algorithms which will try to make the output an optimized one. Okay, so there are different types of second order methods. There is Newton's optimization methods, and there is Broyd and Fletcher method. Many number of second order methods which will try to give you an optimized optimized solution. Okay, it's called BFGS algorithms. You have different types of algorithms. Efficient minimization algorithm using Newton's law. There are so many things. So I will not dive deeper into it and all. Just understand. And there are third order methods which are under processing. Actually, they are not yet invented. Third order methods, I have not specified third order methods here because it is under invention, which is trying to make even more. There are certain set of algorithms, certain set of data which cannot be predicted, which you cannot arrive at a solution. So there are certain type of methods which has to be built even from the scratch. These type of solutions, these type of algorithms comes under third order methods. Okay, so when you take up first order, it's always about stochastic gradient descent. When you speak about second order methods, if it is a larger number of data, it is feasible. The solutions for gradient descents are adaptive training. Inside adaptive training, you have different types of parameters, which is ADA-grad, ADAM, ADA-delta, RMPS prop. There are so many types of solutions we have. If time permits, I'll just tell you what and all are these, and I can show you a demonstration also. And there is the third component, which is called as vanishing gradient. So when we speak about gradient descent, obviously there comes a coefficient, right? There is a solution, you have a coefficient. That's all about gradient descent. When you speak about vanishing gradient problem, it's a phenomenon that occurs during the training of deep neural networks. So it happens when all the gradients, the coefficients, used while updating the network becomes very small. In the sense, the coefficient minimizes itself to a very small value. So when the coefficients becomes very small, we'll ignore it basically, right? So that is called vanishing. Vanishing in the sense ignoring. The one idea we have here is the gradients what we develop for a solution becomes small. So what happens when it becomes small? Obviously, we'll ignore it. That is called vanishing gradient value. Okay, so here that is a problem, and the solution is we are trying to have activation functions which will include the vanishing gradient also. So these are the three major problems we had in deep learning, and we had in machine learning, and that is being corrected, or that is being obtained or given a solution in deep learning. So that is the major breakthrough we had while starting with deep learning. And if you speak about deep learning much more, you have an increase in the computational power, and you have You have an increase in the computational power, and obviously there is a various or a huge usage of GPUs. We all know what is a GPU, right? When you have something like any machine learning technique. So if you're going to use any machine learning, if you're going to solve anything using artificial intelligence, or if you're going to use any image processing method, or any machine learning algorithm, obviously you will have GPUs involved, right? It's called graphics processing unit, GPU. And using this GPUs, we load the data. There will be data sets. The data sets will be processed, and it will be given out, everything, right? So usage of GPUs is huge nowadays for anything, right? For gaming, for video editing, many things, many for many types of machine learning areas, many machine learning applications. We always use GPUs. So when we started with deep learning, there was a breakthrough with the GPUs, graphic processing unit. So, how deep learning works? We are going to understand the work of deep learning. Yes, as from the beginning, I started with the deep learning saying that there is a usage of artificial neural network altogether. So, deep learning is implemented through neural networks. So, as I said earlier, the motivation behind neural networks always about the biological neuron. When you take up a biological neuron, you have a dendrite. The dendrite will receive the signal from the other neurons. I said there are a number of neurons in our body, right? Each neuron is getting connected with the other neurons. So dendrite is something which receives the signal from other neurons and it conducts itself, right? And there is something called a cell body, which will get the input, sums up the input, pushes it towards the output. From there, the other neuron receives it, and this keeps going on. Yes. And there is something called as axon. Axon is another part in a neuron which is used to transmit the signals from one cell to the other. Yeah. So this is the idea of a biological neuron. If you take up the artificial neural networks, obviously you have an input which is called as x1, x2, x3 up to xn, and you have an input layer which receives the input. Yeah. And there is a hidden layer which has the transfer function, also the activation function. I told you this, right? Whenever you have a deep neural network, you have three things to remember. One is input layer, hidden layer, and output layer. Input layer receives the input, whereas your hidden layer has transfer function and activation function. So with that transfer function and activation function, you're going to define it based on your problem. Okay, this is the generalized terminology, generalized work of a transfer function and an activation function. And from there, you get the output Y. And one thing you have to remember is you have something called as W1, W2, W3 up to Wn, which are the weights. Weights are something, the cost of the input. Okay, so when you write anything about the neural networks, or if you're going to define any input in a neural network, obviously you will have weights along with it. Okay, weights in the sense the cost of the input. Okay, so what are the unique characteristics of deep learning? So what are if you take up deep learning, so why you may question like this, why deep learning? Just a second. Okay, sorry. Yeah. So you may think like, why should I go for deep learning? What is the usage? One major problem we discussed about the machine learning was feature extraction. That is done automatically here because as we discussed, overfitting and underfitting are all ignored here. Regularization is ignored, dropped out. So many things, right? So that is the first major thing you have to remember. You have an automatic feature extraction, and it uses high dimensional data for training. But for prediction, it reduces the dimension. That is what we saw, right? Dimensionality reduction technique. Sorry. So for training, deep learning uses high dimensional data, whereas for prediction, it reduces the dimension. So there is dimensionality reduction. Yes, and but the third thing, we saw this as a definition, right? So you're going to define high level feature from low level feature, and also low level feature from high level feature as defined. Yes, and one more thing we have learned about deep learning is we learn what is representation learning. Yeah, you're going to understand the pattern, important uh, links, or you're going to understand the data, how to represent it, and then represent it, right? So that is important. you, I told you that representation learning will be something new for you, right? So representation learning is important because if you take up deep learning, representation learning along with machine learning will constitute deep learning. So representation learning is important. So it's like you're going to understand the meaningful patterns, understand the meaningful data from the raw data. It is never organized. Yes. So the unique characteristics of deep learning is that you're going to have representation learning inside, and it can solve any real world or any type of problems. It can be constrained problem, it can be unconstrained problem, it can be a simple problem, it can be a complex problem. Anything, deep learning can solve anything. Yes. So such examples are like NLP, which is natural language processing, image recognition, etc. So deep learning models can recognize complex patterns in pictures, text, sound, or any other data to produce accurate insights and predictions. So you can use deep learning methods to automate tasks that typically requires human intelligence, such as describing the image or transcribing a sound. Uh, I mean, you're going to hear it, transcribing the sound into a text. If you're trying to convert it, you can use deep learning techniques. So whether it is a complex problem, whether it is a simple problem, deep learning solves it. So there are some of the deep learning softwares, but these are some of the deep learning softwares. There are a number of deep learning softwares. Other sorry. So TensorFlow, Theano, Torch, Keras, Blocks, Cafe, Cafe2, MaxNet, MatConverNet, Microsoft Cognitive Toolkit, Deep Learning 4J, and DLEP. These are some softwares which I use. Okay, because since I said my PhD work entirely relies on image processing, satellite image processing. Sorry. I have worked on all these softwares, but it is not limited to these softwares. You have a number of others deep learning softwares which you can just try to explore. And what are the different categories of deep architecture with algorithm? So if you take up any deep learning algorithm, you will have supervised or discriminative deep learning, unsupervised or generative deep learning, hybrid deep architecture. So supervised is like, as we all know, it is about labeled data, right? You're going to learn data using labeled data, right? Obviously, uh, from machine learning, we understood that supervised learning is all about learning from the labeled data. Same here in deep learning also. Supervised learning is also called as discriminative deep learning. When you take up unsupervised learning, which is generative deep learning, this is what is ruling the world now. Something called as generative AI. Yes, generative artificial intelligence involves generative deep learning, right? So which is always an unsupervised learning. I'll tell you an example, very good example. You can give a picture of a 2-year-old child. and you can predict how the child will look in 20 years. That's called generative deep learning or generative artificial intelligence, where you have not supervised anything there inside the picture, correct? So you're providing it, you're just trying to predict it. That's called generative deep learning or unsupervised deep learning. And there is something called as hybrid deep learning, which is a combination of different types of neural networks or methodologies. So some of the example is like you're going to combine deep learning along with the probabilistic approach. You're going to combine deep learning with a machine learning algorithm. You're going to combine deep learning with the physical laws algorithm, anything. So hybrid deep architecture is the combination of deep learning algorithm and different types of other algorithms. It's called hybrid deep architecture, and these type of architectures are under uh, research for quantum computing. Okay, people, I mean, one another area which is rising so far other than artificial intelligence is quantum computing. And we could find there are people who are trying to invent more type of algorithms, more type of architectures in hybrid deep architecture, which is applied in quantum computing. So we know what is supervised or discriminative deep learning technique, which involves convolution neural network, CNN. Okay, so CNN, the major application of CNN is for image recognition and processing. So especially when the objects are partially distorted or partially obscured. Okay, I mean, if the I mean, some examples of convolutional neural network are, we all use social media, right? So we would have seen people, there is a picture on black and white on some era. They'll make it to color. They'll convert the black and white picture into a color picture, right? And there are situations where you have a photo or frame of someone in one picture. You have to incorporate that person into some other picture. Yes. So in such cases, there are softwares for that. So those softwares use convolutional neural networks. Okay, convolutional neural networks, as I said, is used for image recognition and processing, especially when the objects are partially distorted. Okay, so the architecture goes like this. You have an image, there is a convolutional and max pooling, which is called convolutional layers with pooling layers, and there is a fully connected neural networks. With that, you're going to predict. Okay, so the, say for example, you're recognizing your face, facial recognition. We all have in our mobile phones, we all have in our laptops, facial recognition, facial lock, right? So how is it happening inside our mobile phones? Obviously, there is a convolutional neural network algorithm which recognizes the features of the face. And the second type of algorithm, which is supervised or generative deep learning, which is restricted Boltzmann mission. Okay, so this is one important area in deep learning, where people are, I mean, actually RBM is not actually a algorithm, it's actually a mission. Okay, restricted Boltzmann is actually a mission. It's a generative stochastic artificial neural network mission, which is used for exclusively for unsupervised learning. So whenever you have any data to be I mean, you don't have an organized data, or you don't need any supervision for the output, obviously you can go with RBM type of technique, where the generative model is capable of learning probability distribution over a set of input. It will probability I mean, uh, there is no fixed data, or there is no fixed method of defining your output. It is always about the probability distribution over the given set of input data. So that is always RBM. It's restricted Boltzmann machine. So this RBM was introduced in early 2000s, and it's like to address the unsupervised learning you find in deep learning techniques. So there are two types of layers. As you see in the picture, you have one visible layer and one hidden layer. That's called visible variables V1, V2, V3, and there is hidden variables, which is H1, H2, H3, H4. And the visible layer always represents the input data, while the hidden layer represents the features which has to be learned by the network. And if you speak about RBM, why is it called restricted? Because the connections between neurons and I mean, if you see the neurons, say for example, the input from the visible variable, you are having the connection to all the four hidden variables, all the four hidden functions. Similarly, from variable 2, you have the connections with all the four variables of the hidden function. Also from 3. Yes, but V1, V2, and V3 are not interconnected with each other. They are connected to the hidden layer, but they are not interconnected with each other. So this is called restriction. The restriction among the neurons, among the input neurons is called restriction among the input neurons, and that is why it is called as restricted Boltzmann machine. Okay, so when you take up RBM is a compressed representation of input data, and you always find dimensionality reduction here in RBM. So there are so many things to be discussed in Boltzmann mission. We will see that in the upcoming slides. So as of now, just understand, if you come across RBM, it is always a mission. You're going to restrict your neurons, input neurons, from interconnecting with each other. And there are two types of layers. One is visible layer, another one is hidden layer. Visible layer is all about V1, V2, V3, V4, and hidden layer is H1, H2, H3, H4. Okay. So this is restricted Boltzmann. And there are different types of restricted Boltzmann machines, which one such machine is DBN. So DBN is always called as deep belief network. Deep belief network. That's called DBN. Okay. So what does DBN mean? DBN is always about a deep learning algorithm that uses hidden layers or hidden variables to learn complex patterns of data. If it has complex data, if you get a complex data, obviously you'll use deep learning, deep belief networks to understand the complex patterns of the data, the connections between different types of data. And DBNs are a type of deep neural network which can be used for generative and discriminative modeling. Okay, they're often used for tasks like image recognition, speech recognition, space data, and natural language processing. So these are the different applications you have in deep belief networks. The simple thing you have to remember is DBN is used to identify is used to learn complex data connections between the raw data, and you will have huge hidden variables. Yes, and what and all are the applications for image recognition, space recognition, natural language processing, and for space data you always use DBN. Okay, so the flow goes like this. If you take up DBN, there will be layer by layer training for all the neurons, or for all the layer of neurons which is being created, and you will have an optimized solution coming up after that, which is called as stochastic latent variable. You will get a coefficient for the solution. And obviously it depends on whether you have you have to have a supervised learning or an unsupervised learning, and you'll represent. Finally the representation learning comes into picture. So this is the actual flow of deep belief network. Just a second. என்னாச்சு?
சொல்லிருப்பாங்க போல ஸ்டூடெண்ட்ஸ் எல்லாம் சொல்றாங்க.
Sorry, we have a function here, so that's why. Sorry. Okay, the next one is DBM in deep learning. So DBM is called a deep Boltzmann mission. That's called DBM, deep Boltzmann mission, which is a generative neural network which uses again probabilistic graphical model for learning complex data. So if you take up DBN, you have a hidden layer to learn complex data. Here in DBM, a deep Boltzmann mission, we use a probabilistic graphical mission to learn the complex data. So basically DBMs are used for voice notes, for speech recognition. That is the major application of DBM. If you have high dimensional data, such as whenever you have high dimension data, you can go for DBM, deep Boltzmann mission. So usually to speak about high dimensional data, it's all about a voice recording, which can be high pitch and low pitch. So speech is one major application where you will find deep Boltzmann missions. And there is another technique which is called as DEM in machine learning. So it's called deep, I mean, yeah, digital elevation model or deep energy model. You can define it in two ways. One is deep energy model, or it is digital elevation model. Okay, so as the name itself suggests, this is for the DEM models are used for recognition of images in high resolution. Okay, so to improvise the high resolution, to extract the elements, to generate new products, we use DEMs. That's called digital elevation model or deep energy models. It's called DEM. We always use DEMs in our mobile phones. Why? Because in cameras, we always have a camera focus. And of course, in the new release of different types of mobile phones, we can erase pictures which is being in the crowd, in the photograph. We can erase things and we can add new things. You can improve the resolution. Yes, so for those all applications, we use DEM model, just digital elevation model, or it's called a deep energy model. Okay, so you will get a super resolution in DEM model. There will be, and I forgot to tell you, all the filters we use in our mobile phone, Snapchat filters, everything involves DEM model. So you have filtering process, and whatever modification you make, you can change the shape of the eye, change the shape of the face, you can improve the white contour, everything, right? So these are all comes under DEM models. So you all these different types of image processing are being implemented using DEM model. And the important part of deep learning is autoencoders. Autoencoders is like you have an input, right? And there is an encoder which will encode, and there is a decoder which will decode, and you will reconstruct it. And from the reconstructed output and from the input, you will generate the error between the two. Okay, so as I mean, what was the definition of deep learning? We said that you're going to get the higher definition data from a low dimensional data. You're going to get dimensional data from a low dimensional data. This is what was the definition I told you, right? Another one different definition for deep learning is you're going to define high dimensional data from low dimensional data and low dimensional data from high dimensional data, right? So this autoencoder is the biggest example of that definition. It's like your data is going to learn from the low dimensional form, in the sense the input is a low dimensional form which is getting encoded into high dimensional data. Okay, and from high dimensional data you're going to reconstruct it. Okay, reconstruct it, and from the input and from the high dimensional data you're going to arrive at the error. So an autoencoder is a type of neural network that can learn to reconstruct images, text, and other data from compressed versions of themselves. Okay. Again, reconstruction of an image uses autoencoder. Okay, so if you take up autoencoder is an unsupervised deep learning technique. Autoencoders are never supervised learning technique. Okay, okay, fine. So we are going to have a literature review of different types of algorithms. What and all I have covered is I have covered the different learning algorithm, how their representation learning has been done. Are there any overfitting technique? What are the optimization method? And what are the variants they used? So these are the things I have covered in my review. Basically, to say frankly, I took all this from my PhD research. Okay, so this table is about the categorization of a deep neural network learning algorithm and its resource related approaches. Okay, so there is a CNN algorithm. What are all the CNN algorithms we have? What are all the RBM algorithms we have? What are all the encoders, autoencoders we have? What are all the sparse coding we have? Okay, so these are the different types of algorithms we have. If you take up CNN, it's like AlexaNet, Clarify, SPP, BGG, Google ANet. These are all the algorithms in CNN, in the sense convolutional neural network. And there is restricted Boltzmann, yes, RBM. Inside RBM, you have deep belief network, DBN, deep Boltzmann mission, DBM, deep energy model. This is what I told you, right? Now, digital elevated models, something here, right? Digital elevated models or deep energy models. Yes, yeah. These are the different types of Boltzmann machines we have, and autoencoder, as I said earlier. Sorry, as I said earlier. Just a second, my laptop is running out of charge. Yeah. So autoencoders, I have sparse autoencoder, denoising autoencoder, and contractive autoencoder. So if I start speaking about each of the algorithms, it will take so much of time. What I'm trying to do is we are running out of time because as such, because um, due to time limitation, I'm just giving you, these are all the type of learning algorithms we have. And there is another type of coding which is called as sparse coding in neural networks in deep learning. Okay, sparse coding means representing a signal as a linear combination of few atoms. Okay, few atoms in the sense a signal representation. Okay, a signal representation of neurons. That's called sparse coding. signal representation, in the sense it can be a sine wave, it can be a cosine wave. Yes. So you're going to represent your what neurons in signal format. That's called sparse coding. So different types of sparse coding. As sparse coding is one of the type: Laplacian sparse coding, local coordinate coding, and super vector coding. These are the different learning algorithms we have in deep neural networks. And the second one is all about representation learning, right? So how are we going to represent our learning technique? So see, um, uh, there are see the this is as I said earlier, this is my research area. So this is all about my literature survey. So one first, I mean, if you take up representation learning, you're going to identify the possible patterns inside your raw data, right? So how am I going to represent a low dimensional data from a high dimensional data is the problem, is the representation problem we have. The suggested contribution is forming deep Boltzmann missions will give you a representation of high dimensional data from lower ones. For vice versa, you can go for autoencoder. Yeah, from low to high, you have autoencoder. From high to low, you can go for Boltzmann mission. Yes. And the next feature representation is all about um, getting a hash function learning. Yes. And how a feature can be learned, in the sense the data will be compressed. So how can I extract it? How can I learn it? So what we can do is, it's all about supervised deep hashing technique along with the retrieval and mining techniques. That could be the possible solution for this. And the third research focus on representation learning is all about the success between convolutional neural networks of supervised and unsupervised learning. CNNs always comes under supervised learning. But what happens if I represent a CNN in unsupervised learning? That was the research focus. And what could be the answer for it is, you can create a deep convolutional generative adversarial networks. It's called GAN. Yeah, there is a network which is called as generative adversarial networks, called GAN. Okay, GANs and transformers. They play a very important role in generative AIs. Yes. So by creating deep convolutional GANs, you can bridge the gap between the supervised and unsupervised learning of convolutional neural networks. The third topic is all about overfitting techniques. You know what is overfitting, right? Giving so much of conditions to find out a solution. So what happens if the overfitting is large in neural network and the data set is very sparse? What you can do is, you can drop out the data which is not useful, or you can have a stochastic pooling, in the sense you can be positively optimal about the data, or you can implement a flipped image in the sense a prediction. This could be the data. It could be a positive wave data. It could positive wave data, in the sense you're possibly saying, yeah, this is right, this is always right. You're going to give it as a positive way in the sense, it's like, what is flipped image? Myself, the image of, again, the reversal image of me. That's called flipped image, right? So I am a positive one. I'm positive. So the flipped image will also be positive. So if I have a data which does correctly, again, if I'm going to flip it, what will happen? The generated data will always do correctly, right? So that is one solution you can give for overfitting. And the second thing to focus is like how a CNN's transfer learning is actually a function inside the hidden layer. Yes. So if you have transfer learning function inside convolutional neural network, how can I improve the sum product network in a probabilistic inference? Okay. So this is something deeper to discuss. So we have a limited time, so we cannot go in deeper. To say the overview, transfer learning is a function which involves sum and product of the entire network. Okay. and you will have a probabilistic inference also in it. Okay, this is the situation. This is the actual situation. So what happens if the data set coming in is sparse and it is not completely full? What happens here? That is the problem. That's the research focus. And what could be the contribution is, you can just write a theoretical framework, something called as zero shot ranking. It's called zero shot ranking in the sense, if the data is sparse, you're going to add zeros to the sparse data. Okay, you're not going to omit it. You're going to add zeros to the sparse data and do the transfer learning, give out the sum and product network, get the answer. And the fourth one is about optimization methods. So what are the optimization methods we are going to use here? So obviously, if you speak about any optimization technique, there comes a word which is called as gradient descent. Right? So what is gradient based optimization in neural networks? See, you have, this is what I said. You have certain networks which are like Adam, Adagrad, RMS prop, momentum, BFGS, Kalman based stochastic gradient descent. So much first order and second order optimization methods can be used. I already gave an insight about what is a first order, what is a second order, and what is a third order methods. Correct? Yes. The second one is about to develop an accelerator which has a state of art accuracy with minimum consumption of CNNs. It's like the energy consumption of convolutional neural network should be minimum. That is the scenario. So what could be done here? So what you can do is you can develop an energy efficient reconfigurable accelerator. Okay, you're going to you're going to implement, you're going to develop an energy efficient reconfigurable accelerator of deep convolutional neural networks. This is being implemented using zeros and zero skipping and gating. In the sense, if you don't have the exact data, you're going to skip it out. That's called gating. Zero skipping in the sense, whenever the data is found to be zero, you're going to skip that. That's called zero skipping. Okay, so it's all, these all comes under data pre-processing methods. And finally, deep learning variants. Deep learning variants, what are the different types of variants we have? One important variant we have is all about deep neural networks, okay, which implements support vector machines. So that could be, you can just incorporate two heterogeneous classification technique like CNN with support vector machines can be included together for finding different variants in deep learning. Also, what happens if KNN classification task performs optimized? Usually, if you take up KNN, it just predicts, and the prediction will be approximate. It will never be accurate. That is a scenario. So, if that is the situation, what can I do? What happens if K-means or KNN classification gives you an exact or gives you an optimized solution? That is the research focus. What could be the solution for it? I could develop a convolutional nonlinear feature for K nearest neighbor method, which will outperform the existing KNN classification. Okay, so just remember, people, one thing: whenever you take up convolutional neural network inside any different types of deep learning algorithm, obviously there will be a rise in the performance. That is one thing I have observed in all the research papers I have gone through so far. So application literature review. So we are going to discuss two things. One is methodology, which is an application of deep learning. Second one, which domains the applications of deep learning is being done. So the deep learning has been applied in so many ways in to solve real life problems, which are, for social applications, okay, in the sense, say for example, like, say, I'll tell you an example. Reconstruction of a picture. Okay, that is actually um, a sentiment analysis, or to find which comment is genuine, or which comment is fake, or which is being bought with money. There are people who will pay money for you to put your comment, right? So there could be like that, reviews, fake reviews, right? So these all comes under sentiment analysis. So if you take up sentiment analysis, that is one major application of deep learning. And what you can do is you can create classifiers, yes, along with the features, gradient features and gradient approach. That is MSG. It's a gradient coefficient, a stochastic gradient feature, and also with gradient approach, which is GA. Yes. So when you create a classifier with the contribution of identifying, with the basic idea of identifying which is right, which is wrong, there could be situations where you can reconstruct the face, right? It could go wrong also, it could go correct also, right? Whenever there is a 50-50 possibility of going correct and wrong, if the prediction, say for example, if I'm going to predict whether the given review is fake or whether the given review is actually truthful, the prediction can go wrong and it can go right also, right? So whenever there is certain situations, you can go for creating a classifier with stochastic gradient along with the gradient approach. And there is a recommendation system. This we always see in all our mobile phones, right? When you try to Google something, whenever you go for any other networking site like Facebook, Instagram, Twitter, or Flipkart or Zomato, wherever you go, you will find the recommendation of that particular product, right? So that's called recommendation system. So for developing a very very good, very efficient recommendation system, what you can do is you can create a Bayesian stack denoising autoencoder. It's like the better option is to go for an autoencoder. So there is a specialized encoder technique which is called as Bayesian stack denoising autoencoder. It's called SDAE technique, which will help you in getting you a very good recommendation system. And there are certain applications in day-to-day activities where you have business scoring, right? Credit scoring plays a very important role. So when you want to have a credit scoring using credit default swaps, these all comes under the stock market and share market. I'm not peculiar about it. I don't know in detail about that also. But there is a concept of credit scoring where they'll just swap the default credit, and they'll score it. Okay, so it's something like that, I think so. So if for that, you can develop a recommendation system which uses MLR, MLP, support vector machine, and along with deep belief networks, DBN. All these minings which are done in sharing and stock markets and shares and all, the auto there are things which runs automatically, right? So for that algorithm, for that implementation and all, we always go with deep belief networks or Boltzmann machine networks. And vein morphological patterns, this comes under biomedical. To recognize the veins, to recognize the arteries, we can go for, again, whenever, just remember people, whenever there is a image reconstruction, you always have convolutional neural network along with stochastic gradient method. So there is a prediction process of behavior. So the behavior of a patient, you're going to predict it. You can use a recurrent neural network with TensorFlow. And one thing you have to remember always is RNN is a place where RNN, LSTM, long short term memory, it's called LSTM. Yes. So RNN is a place where the world is under research. Okay. So it's like you're going to train a sequential data, and um, you're going to, I mean, say for example, chatbot, chat GPT, right? So RNN's biggest example, RNN's biggest application is ChatGPT, where certain sequential, say for example, if you give a prompt correctly, you'll get huge number of recommendations, right? So RNN is a deep learning model that is trained to process and convert a sequential data input into a specific sequential data out. In the sense, when you give your prompt correctly, you'll get the prompt exactly. Okay, so this is the next major application. And there is emergency based alert system. Obviously, this is a deep learning concept with IoT. Yeah, we know all these things. CCTV, API, there is a linkage, there is a convolutional neural network. Yes, these are the applications. I started with the application. Yes, application of DL's methodology. We are discussing about the different types of methodology, and this is the applications of deep learning domains. So obviously, when you have a recommender system, you have an opinion mining, sentiment analysis, and you can refer this paper. Yeah. Yeah, and if it is a social application, again, opinion mining, facial recognition, and sentiment analysis. Enhancing deep learning sentiment analysis paper is one paper where you can refer. If you go for medicine, medical diagnosis, you have medical image analysis paper in 2017. And for credit scoring and all, I told you, right? Stock market prediction and all. So for finance, you have deep learning approach for credit scoring using credit default swaps. That's a 2016 paper. For transportation, traffic flow prediction, we always find this in Google Maps, right? So traffic flow prediction, and there is an enhancement in the prediction process that is found in 2017 paper by Paulson. And for business, I said about the mining and all, right? So for that, you have Everman paper in 2017, and there is an emergency alert system. The paper Kang et al. With 2016 has an emergency alert system defined with a clear architecture. And there is another area which deep learning plays a very major role. It's agriculture. The identification of plant using various morphological patterns, where D, B, N and all will play a huge role. So what are the applications of deep learning? We know all those things we see in the day-to-day life is all about deep learning, right? So for machine translation, when you give data in one language, you get it translated in another language. To identify the object in the photograph, for generating text, for colorization of black and white into color, for automatic game playing, we all use applications. These are all the applications. We use deep learning everywhere. So see, Google Lens is one of the major applications of deep learning, where you're going to, take a picture of one particular object, one particular image. The image or a video or a live feed is being compared with the data set which is being there somewhere in the cloud, and Google Lens will tell you, say for example, here it is a type of flower, right? So it will tell you which type of flower is, where this flower will blossom, which country is the native of everything regarding the flower. Then if you take up the restaurant's sign, you'll get the reviews about the restaurant. So Google Lens is one of the biggest applications of deep learning. Excuse me. The second application is Google Translator, right? Where you will scan the type of text, one type of text, and you'll get the other. Say for example, if it is in Spanish, you don't understand Spanish, right? So you just start with you scan it, you translate it, you'll get the English translation, or whatever language you want to get it translated, you get the translation, right? So some languages are getting translated into English language or whatever language you want, right? So this is also a type of image recognition, or you can say it as a text conversion also. And there is instant visual translation. Say, for example, there is a signboard which is in Korean, and that is getting translated to English, right? Similarly, in an English word stop is getting converted into Kannada, right? And this is the area which is under research, and something is happening, brewing, and we'll get an output soon. So, which is like self-driving cars. You are just able to, I mean, things you have to remember is you have to get the GPS signal, you have to see the signal on the road, you have to go flow with the direction, you have to reach the destinations. These are the things you have to remember when you start with the self-driving car. And automatic machine translation, like if you want to translate text into another text, right? Say, for example, from Mexican to English, from English to Spanish. So these are the trends in deep learning. It's like identifying models with a few training data. One major problem we always face with deep learning research is we need huge models, huge training and testing data. So one research what is going on is, with fewer data, how can I design a powerful model, and how can I adjust the parameters and regularize the technique, and what are all the, I mean, most of our deep applications in our mobile phones are constructed using deep learning. So what are all the algorithms left over which can be implemented in mobile devices, and how the deep learning network is playing a very good role, and forming a hybrid model, a combination of probabilistic autoencoding and manifold learning. How is it going to happen? And if it is a nonlinear networked control system, how am I going to apply it in deep neural networks? And how can I apply supervised, semi-supervised reinforcement learning approaches in deep learning for complex systems? And how can I implement deep KNN algorithm with deep support vector machines? So these are the research or trends that are happening in deep learning. And what are all the challenges we find in deep learning? One thing is there is a high computational cost, because obviously you, as I said earlier, we need GPUs, right? Graphic processing unit, to train and test data. So obviously cost plays a very big role. The second thing is there is overfitting problem whenever your data set is small. So we have to take care of it. And when you take up the optimization, there will be local minima. And in some cases, you ignore the local minima and we use first order method. Okay. So it is not necessary that this will provide you a very good optimization result. So that is the major issue. And in some situations, people will never understand the underlying architecture of deep learning, and they have very little or no understanding about the deep learning architecture. So without the knowledge, they will try to implement the algorithm, which will be a disaster. So that is basically a problem from our side. When we implement something, we have to learn and implement. That is one thing. The next thing is time complexity. Time complexity about, I mean, whenever you have a complex data or a complex problem, the time taken will be huge. So that is one thing you have to remember about deep learning. I have a use case for deep learning. The problem scenario is, suppose we want to create a system that can recognizes the face of different people in an image. How do we solve this as a typical machine learning problem, or how can I use a deep learning approach? So what we can use is, using a classic machine learning approach, we'll define the facial features such as eyes, nose, ears, etc. So the system will identify the features for which person it is, and do we have any database regarding to that person. It will pull it out, give you the output. So this is the classic machine learning approach. But when you go with the deep learning approach, deep learning takes one step ahead. What happens is when you have a deep learning, which will automatically finds the features, classify the features using deep learning networks. Whereas when you take up machine learning, you have to define your features manually. But when you take up the features in deep learning, it defines itself automatically. So that is the biggest advantage of deep learning approach. Sorry, I got some persons here. Yeah. Okay, so that is deep learning approach. So when you take up the facial recognition of the practical application, you will have an input layer, you will have a hidden layer 1, hidden layer 2, and there is an output layer. So when you take up the hidden layer, the hidden layer 1 will extract the face features. Hidden layer 2 will map you with the database, and it will produce you the output. So you have a face recognition a procedure where you have prototype of faces, and the face is detected, your features are extracted, and the features are mapped with the database, retrieved and from the the output is retrieved from the database, and you're being classified. If it is recognized, you're getting the recognized result. Okay. If suppose I'm giving a face as a query, what will happen? The face will be pre-processed. The features of the face will be extracted. Already the features of the prototype is ready, and the classifier will classify which type of face it is, and there will be the output. So this is phase 1 and phase 2. Phase 1 is always about training the data. Phase 2 is always about querying the data. Okay, so see, phase 1 includes face deduction, extraction, and the model is extracted from the feature database. Phase 2 is you're deducting the face, pre-processing the face, extracting the feature, recognizing it. That's it. See, if it is a face deduction, you're going to enroll your face. That is, you're going to put it as a data using histogram of oriented gradients, HOG. And after that, you are just extracting the feature using deep convolutional neural networks. Yes, you're extracting this and you're keeping that inside Word database. So this is the step 3, which is enrolling your face feature inside the database. That's called enrollment phase. And the fourth one is recognition. Yes, so this is how data is being stored. I'm giving a query of a face, right? So what happens here, when I give the query as a face, my face is deducted using from the HOG, which is histogram of oriented gradients, HOG. From that, I'm recognizing the face, and there is a pre-processing, right? Using Kalman filter, adaptive rednecks, multi-scale self-quotient, Gabber filter, etc. Using that, I'm going to filter out the eyebrows, face, eyes, nose. Yes. And now, what will happen? I'll extract the feature. I'll recognize it, right? In the recognition, using DCNN, that is Deep Convolutional Neural Network, I will recognize the person's face, and using there is a recognition happening after feature recognition, and you have to match it with the classifier. That is what is done here, right? See, you're extracting the feature, and there is a prototype of faces. which is also having a feature database. You're going to compare feature database with feature extraction inside the classifier, and you're getting the recognition result. That is what is said here. So you're recognizing it using different types. The classifier can be any type. It can be SVM, it can be Bayesian classifier, Euclidean classifier, anything. And from there, you extract the output. So finally, I have to conclude my session. So deep learning is actually a representation learning method and a new state of art for learning or for featuring the unlabeled data. So deep learning always focuses on learning unsupervised algorithm. That is one thing we all have to remember. And there are different types of deep learning architectures, and there are different types of algorithms which has to come together to give us different enhanced techniques for better performances. And there are several theoretical concepts which has to be practically implemented as of now. They are still on theory. They have never been presented. And when we take up any complex real world problems, uh, deep learning gives you an automated feature extraction. Whereas when you go for machine learning, it is always about manual entering of data, feature extraction. And deep learning is always a bigger problem in deep learning is always about the hardware resources and the computations we need. So if some people who are trying their research in deep learning can try on this area to reduce the time complexity, to reduce the cost of implementation of deep learning, that will improve the usage of deep learning for wider audiences with broader applications in future. And these are the references I referred for the preparation. And I have to thank Pencil Builds India for helping me, for approaching me for this session. I've been associated with them for a longest time. And I should thank Dr. Sangeeta for giving me an opportunity to give the insights of what I have learned so far uh, to my community of people. Thank you so much. Any queries could be addressed. Yeah.
Thank you, ma'am, for your wonderful session. It was very great session, ma'am. Thank you so much, ma'am.
Thank you. Thank you. Thank you so much.
Let's go for the query session, ma'am. Any queries from participant side? Okay.
Please go on.
Suchitra madam, it's a wonderful session. You have explained every concept clearly. Thank you very much.
Thank you.
If no doubts, shall we wind up the class, ma'am?
Yes, madam. I think we can wind up. Yeah.
Okay, thank you so much, ma'am. Thank you, ma'am.
Thank you. Thank you so much. Yeah.
Thank you.